Right click on desktop, new folder, name it as inverter, create. Open this inverter folder, right click, open in terminal, type csh source slash home slash install slash cshrc, enter, type virtuoso, enter. Now in this cds.log window, go to file, new, library name is inverter, attached to an existing technology library, OK, select here GPDK 180, OK, you will get message inverter library is successfully attached to library GPDK 180. Now go to file, new, create cell view, library, select inverter, cell name INV, it is user defined cell name, click on OK. This window is schematic editor window. You draw inverter schematic here. For that, go to create instance, library, GPDK 180, cell, PMOS, enter. You can change here total width. I will keep 2 micro, place it here. Next, create instance, place NMOS, GPDK 180 library, NMOS, 2 micro, total width, hide, and place below the PMOS. Now place input and output pins. For that, go to create, select pin, input pin VIN, VDD and VSS. Direction is input, hide. Now place these pins. VIN is left side, VDD on top and VSS is bottom. Now for output, again go to create, select pin name is Vout, direction is output, hide and place. Now connect all these pins. For that, go to create wire, select wire, PMOS source to VDD, PMOS substrate to PMOS source, PMOS gate and NMOS gate is shorted, connect to input pin VIN. Now PMOS drain and NMOS drain are shorted, connect to Vout. Now source of NMOS is connected to VSS and substrate of NMOS is connected to source of NMOS. Now check and save. Icon is there, you click on that. On CDS dot window, you will get inverter schematic is saved with no error message. Now create symbol. For that, go to create cell view, from cell view, no changes in this window, click on OK. Now arrange input and output pins. VIN is left pin, Vout is right pin, VDD is top pin, and VSS bottom pin. Click on OK. This one is inverter symbol. You can retain this rectangular box or you can draw the symbol. I will retain this rectangular box only. Now save and check. Here inverter symbol is saved with no errors. In the cds.log window, go to File, New, Cell View. We have to check this inverter schematic. Library is inverter, cell name is test, inverter underscore test. View is schematic, type is schematic. Then click on OK. You will get another schematic editor window. Here you have to place inverter symbol. For that, go to create instance. Library name is inverter, cell name is INV, view is symbol, hide. Place this symbol. Now give inputs to this symbol, inverter symbol. For that, go to create instance. Library name is analog lip, cell name is vpulse. Symbol. Click anywhere here. You will get this window. Now enter these values. Voltage 2 is 1.8. Period is 20 nano. Rise time is 1 nano. Fall time is 1 nano. Pulse width is 10 nano. Half of the period. Hide and place left side of the symbol. Now again go to create instance, analog lip, take VDC. DC voltage is 1.8 volt. Hide and place VDC. Positive terminal of VDC is connected to VDD. Now for capacitance load, instance analog lip, library analog lip, type cell name as cap. Capacitance is 0.1 picofarad. Hide and place. Escape. Now for ground, go to create instance, library analog library, cell is ground. Okay. Hide. Now connect all these points. For that, go to create wire, select wire. Now check and save this test bench schematic. Again press this icon, check and save. You will get this message in cds.log window. Inverter test is schematic is saved with no errors. Now launch, go to launch, Select ADEL window. Analog Design Environment Library window. Setup Model Libraries. Select 180 nano. Unselect all this. Only select 180 nanometer technology. Click on OK. Now go to Analysis. Choose. Select Transient Analysis. Stop time is 200 nano. Click on Moderate. Then click on Apply. Now select DC Analysis. In DC Analysis, save DC operating point. Select this. Sweep variable. Select component parameter. Select component. Select, click on this input V pulse. Select DC voltage, first option. Click on OK. Now sweep range is 0 to 1.8. OK. Now select outputs. For that, go to Output, to be plotted. Select on Design. Before that, you can name the wire. For that, go to Create, wire name. In name, type V in space V out. Hide. Click on this input wire and V out on output wire. Now go to Outputs, to be plotted. Select on Design. Select input wire and output wire. Now run the simulation. This one is inverter waveform, simulation waveform. This is transient response and DC response. If input is 1, then output is 0. If input is 0, output is 1. Verify inverter output waveform. Now calculate delay. For that, go to Tools, select Calculator. Here select Wave, uncheck this clip. Go to Function panel, select Delay. Signal 1 is input waveform. Select V in. Place it in signal 1 and output 2 is output waveform. Threshold voltage is 0.9 volt. Threshold 2 value also 0.9 volt. Edge type 1 is rising and edge type 2 is falling. Click on OK. Run the buffer. You will get this TPHL value. Now calculate TPLH value. For that, again go to Function panel, select Delay. Signal 1, select input waveform and signal 2, output wave. Threshold voltage is 0.9 volt. Here edge type 1 is you select falling and edge type 2 is rising. Click on OK. Now run the buffer. Add these two values, and average of these two values is total propagation delay. This ends inverter simulation. You can save this state of ADEL window. For that, you go to session, save the state, and click on OK.